more time. So what are data types? So how many data types we have? We will see all of them. So did you all go through this exercise?
Yes, sir.
Okay. So we'll see that. Okay. So maybe we'll conduct exam, then we'll, so you will come to know. I need to cover one more JVM architecture. Let me cover JVM architecture is important. Okay. So let's cover, I'll cover a variable time. I'll cover JVM architecture, but let's go now. So data types, right? Data types. D in the order, you can find in the alphabetical order, data types. So data type specifies the size and type of values that can be stored in a memory. So if you want to store in a particular memory, how much size it is occupying, what type of data you are storing, what type of value you are storing there. So then you're going to use a data type concept. You're going to use a data type concept. And data types are two types: primitive data types, non-primitive data types. See that? Primitive data types, non-primitive data types. And primitive data types are again categorized into 8 types. So Boolean, char, byte, short, int, long, float, double. These are the 8 primitive data types. And non-primitive data types we have, so multiple values you can store in the non-primitive data type. Single value you can store in the primitive data type. But what are the non-primitive data types? String, array, enum, interface, class. Any class, any interface, any enum, arrays, string, all comes under non-primitive data type. So data type means don't think only this Boolean, char, byte, short, int, long, float, double. In the Selenium, you will use only non-primitive data types as a data type. Most of the cases. This very rarely you will use as a data type, means you won't use this much. You will use only these concepts in the WebDriver. When you're storing a data, or when you're declaring a data type, means there you will use either interface name or class name or enum name or array name or string type. These are the things only you will use in the Selenium. Most of the cases. That's why data type means both, not only 8 primitive data types. You have this, any string class, string is only one class only. String class that's available in java.lang package. Array is another concept which stores many values at a time. But here in this primitive, you can store only one value at a time. Enum means many constants you can store in the enum. And interface, it contains many things like a class. This is also like a class. But so there is a difference. So class is created with the class keyword. Interface is created with interface keyword. Class inside, you know all the members, right? Like variables you can declare, methods, constructors, blocks you can declare. But here in the interface inside, only static final variables, abstract methods will be there. Some default static methods also you can write in the interface current latest versions. You can see a lot of new things that I'll show you. Okay, so we don't want all the things, but just Java 8 things enough. Okay, so let's see what is that. Okay, So now what is this one is basically data types are, see, so the sizes are going to be very important here. You should know the size. Character occupies 16-bit of memory. Byte occupies 8-bit of memory. Short occupies 16-bit of memory. Int occupies 32-bit. Long 64-bit. Float 32-bit. Double 64 bits. Can you see here? Float and integer are same size, 32-bit only. Long, double are 64-bit, same size. But the data types are different. This is the float and double. I'll explain one by one, okay? So don't worry about that. So integer family is byte to, short to, int to, long. These four are integer category. If you want to store integer with data type, like a 0 to 9, all numbers only, then you will use a byte, short, int, long. If you want to store a floating point values, float or double you can use. Float or double you can use. And you want to store a single character, then you can use a char data type. Single character that will be represented in single quotes. The value is enclosed in single quotes. And a Boolean, so you will use a true or false. You can store true or false value. True or false, you can store in the Boolean data type. So that's the primitive data types. And let's go on in deep, one by one. First, Boolean. So Boolean means only two possible values. One is a true and false. So your right side value is giving a true or false. Then left side, what data type you need to take? Data type. Yes. You have to take a Boolean data type. So you are storing a Boolean data. Left side should be data type Boolean. So like this. See that? Boolean B equal to true. That means what is this assignment operator will do?
Right side value to left side variable.
Right side value?
Copying the right side value to the left side variable.
So right side value is copying the
left side value.
Left side variable, this variable. That's this assignment operator responsibility. So Boolean B1 equal to false. Then Boolean Bn, so no value at all. Then what is the default value? The default value for a Boolean is false will be there. So if you don't give any value, default value for the Boolean is false. Now see, int x equal to 20, int y equal to 10. So again, I told you already these things. Now, conditional operators, greater than, less than, greater than or equal to, less than or equal to, double equal to. So all these operators you will use between numbers. The conditional operators you need to use between numbers only. The result will be Boolean value. The result will be a Boolean value, true or false. So Boolean B2 equal to x greater than y. Boolean B3 equal to x less than y. Boolean B4 equal to x double equal to y. So that means, see that. What is the x value we have given? 20. What is the y value? 10. So 20 greater than 10. True or false? True. So that means, so B2, what is the value in the B2?
True.
True. Now x less than y. So that means x 20 less than 10. So what is the value? We'll store in the B3? False will store. So Boolean B4 equal to x double equal to y. 20 double equal to 10. True or false?
False.
False. That's why
False.
B4 will contain false. So like this, based on the right hand side output, you have to take the left-hand side data type. So then see x plus y, 20 plus 10. How much? 30. 30 is what data type? 30 is what data type?
Integer.
Double.
Integer.
What, sir?
Integer.
Integer, sir. Why double, sir? Double means what? It's a decimal value should be there. 30.00 or 0103 like that. That's a decimal double, sir. Float
Okay,
and
sir.
double is decimals.
Okay, miss.
So these are all integers. And then logical operators, we have AND operator, OR operator we have. So not equal operator. So Boolean B5 equal to B and B1. So what is the B value? What is the B value?
True.
True.
So and B1. So and means what? R means what? You should know. Not equal to means what? You should know first these. Understand, okay? If you understand this concept, it's easy. These are all going to be used in the logical programming. More logics to build. You should know these concepts. Very, very important. This less than, greater than, equal to, this AND operators, so OR operators, you should know very, very well. Okay? AND means both should be true, then the result you will get a true. So let me show you our tables here. Very nice tables I have given. See that. Variable 1 value true and variable 2 value true, then result 2 is going to be true. So variable 1 value true and variable 2 value is false, the result is going to be false. So variable 1 value is false and variable 2 value is true, result is going to be false. Variable 1 value is false and variable 2 is false and false. See, can you see this? If any one is false, what is the result you are getting in the AND case?
False.
False. When you are going to get a true in the AND case?
Both are true. If
Both are
true,
true,
then
only you will get a true option. Otherwise, you won't get a true. That's the AND case. Okay, so that's the AND case. AND means, remember, both variable values should be true. Then only you will get output true. Otherwise, in any one case, it's going to be false, not equal to. So first variable 1 value is true, not equal to false. This is true, right? Not true, not equal to false. Correct, right? That means the result is going to be true for you. True not equal to true. So it's a false. True equal to true, but we are saying not equal to true. False not equal to true, right? That's why your result will be true one. False not equal to false. So that's wrong. False equal to false, but we are saying false not equal to false. So the result is going to be false. Then R case. R means any one is there, any one is true, the output is going to be true. See that? True or true, output true. True or false, result is going to be true. False or true, result is going to be true. False or false, result is going to be false. So in the R case, please catch here. Only result is going to be false in both are false. If any one is true or false also, true only will get. That's the difference between or and and. So is it clear? Follow these tables. That will help you a lot, okay? Now, based on this, you see that. Now, what is the B value? True. True and B1 value. What is the B1 value?
False.
False. True and false. What is the output?
False only.
False.
False.
False only. Thumb rules. You need to remember thumb rules, guys. And means both are true, only true you will get. Or means any one true means you will get a true. These thumb rules you remember, you want to know, miss the logics. Very important, these logics. So don't neglect this. Understand properly. Okay, so now false will store in the B5. Next, B or B1. Can you tell me the output?
True, sir.
So B is true or B1 is false. True or false? What is the output?
True.
True. So true will store here. B not equal to B1. True not equal to false. Correct, right?
True, sir.
So you will get a true or false here.
True.
True. So true will store here. So this is the kind of things. Please remember, and these are very important logics. Many places people will use this undo or not equal to. Okay. Next. So that's a Boolean. Boolean, are you all clear? When you will use Boolean?
Yeah, true or false values.
If you want to store any true or false values, we're going to use
Boolean.
Boolean. Okay. Next. Char. So char data type. So it is used to store single character in memory location. Then you will use a char data type. So char data type you have to use. The value you should enclose in single quotes. So char data type. So default value is, so this is the default value, Unicode we call this. And the char data type is 16-bit of memory it occupies. 16-bit of memory it occupies. Can you see this? Char C equal to capital D in single quotes. Char C1 equal to small a in single quotes. Char C2 equal to dollar in single quotes. Char C3 equal to, so the empty space. Anything, right? This cap letter or a small letter or a special character or spaces or numbers, all these are characters. So if you declare one-time character, how much space it occupies? How much space it occupies, sir?
16-bit.
16-bit of memory occupies in the memory. Now, why this is not valid?
There are two characters.
Two
characters.
Number and
Can you store two characters in the char data type?
no.
No, Ramesh.
Only one character you can
One
store,
character
not
is-
two. That's why that is wrong. There is no number. Number also character, madam. Okay? Number also character only. If you enclose in single quotes, it's a single character only. Numbers, so alphabets, so special characters, so all these are spaces, so all these are characters only. Vowels, so consonants, so everything is, if one character you are writing, that's a character only. Char data type you have to use. So this one, why it is invalid is more than one character you are storing in a single quotes. That's not possible. That's why it is throwing it is going to throw, if you write like this, it will throw error for you in the Eclipse, compile time error it will throw. So integers, as I mentioned very clearly, integers. So we have 4 data types to store integer data. One is byte, short, int, long. Byte, short, int, long. So the byte data type is a 8-bit of memory it occupies. Its minimum value is -128 and maximum value is 127. So that's the byte data type. Very small integer numbers. If you want to store, you can use a byte data. So byte B4 equal to 5. Short. The short data type is going to occupy 64-bit of memory. And so this is the values. -32,768 is the minimum value. And 32,767 is the maximum value. Short S equal to 1. Next, int. So int is one of the data type to store 32-bit memory size it occupies. To store any integer values, you will use int. Generally, we'll use integers and longs, right? And byte is very small. If you want to store, you will use byte. But this one, 32-bit memory, it occupies. So the minimum value is -2 power 31 and maximum value is 2 power 31 minus 1. That's the minimum and max values, how you can store. So int I equal to 10. So long. So the long data type is a 64-bit. So values it will store. And the assigned long has a minimum value of 2 power 63 and maximum value of 2 power 63 minus 1. But this is the very bigger numbers if you want to store, bigger integer numbers, then you will use long. So long L equal to, bigger integer numbers if you want to store. And at the end, make sure you write a capital L. Capital L tells you it is a long integer. Other than that, nothing. Nothing this L will do is nothing. Just saying that it is a long integer. To represent a number is a long integer number. That purpose people write the L capital L. So see this int A equal to 5. And so this is the compact code. What you are doing here? You are declaring a variable and assigning a value. But what you are doing here? You are declaring a variable in one line. And the next line, what you are doing? What you are doing in the next line? Assigning. This is the assignment operator, means assigning the value to A. Now A contains how much here?
5.
Others.
5, sir.
5. So int B equal to 6. This is the shortcut. This one is declare a variable, then assign the value. Here int C equal to 7. Declare a variable and assign the value. Here first declare a variable in single line. Another line you assign this C value in the next line. That also you can do. So int D equal to this C plus 1. See this variable I am using. Now what is the D value?
8, sir.
8. So int D equal to C plus 1. So D you assign and D equal to, now here you are using the same variable you are using below, C plus 1. String S equal to I am amigo. Here string S you declared and assigning a value in the next line. So both are same. Either this one and this one is same. So please catch all these points, very important. Somebody will declare and later they will assign the value for that variable. Sometimes people will declare and assign the value, same line. So to store the decimal values, we have two data types. One is a float, double. Float occupies 32-bit of memory, okay? And float F equal to 3.6 capital F. 3.6 capital F. Double, the double data type is so it is going to occupy 64-bit of memory and it's going to so have a decimal values like this. Bigger decimal values if you want to store, you will use this. So double D equal to, so this is bigger decimal values. So that is the main concept of all data types. So another very important concept, why we will get a type mismatch error. There are two reasons. Left hand side and right hand side, both the data types are not same. You will get a type mismatch error. First reason. Second reason, left hand side variable memory size is smaller than right hand side memory size. Right hand side variable memory size is bigger. Left hand side variable memory is smaller. And you are using assignment operator. That means bigger memory size data you are storing in the smaller memory size. Will it fit? It won't fit, right? So that is the reason. These are the two cases you will get a type mismatch error. Then how to solve them? By using typecasting. So what is typecasting? So when you are assigning a bigger memory variable value to lower memory variable value, you will lose the data. So in order to, so you don't want to lose the data, then right side variable, you insert in the left parenthesis and write the left side variable data type. That means you are converting right side variable data into left side variable data format. That is called typecasting. So this is a pure definition is this one. It is a process of converting the value of one data type class interface into another data type class or interface is called typecasting. So what is the typecasting? Process of converting the value of one data type class interface into another data type class or interface is called typecasting. So syntax is data type variable name equal to bigger memory variable name or value. And so see that interface 1 variable 1 equal to interface 2 variable. So can you see here, this is the typecasting. What I'm doing here, right side bigger memory variable and left side smaller. So I'm converting right side also to left side format. Now both left hand and right hand side same data type, then your issue will be solved. So here is the examples. Int I equal to 50. Short S1 equal to I. So I is an integer data type. S1 is a short. Now here you will get a type mismatch error. Why? What you are doing? What is the size of integer?
32.
32 bits.
32 bit. What is the size of short?
16.
16. So that means 32 bit data you are copying into 16 bit. Will it fit?
No. No.
That's why you will get a type mismatch. Both are same data type, integer family only. Integer short, same integer family. But here the problem is the sizes are not matching. So the memory sizes are not matching. Right hand side memory size is more. And this assignment operator, what it will do, it is trying to copy into small memory size. And that's why you will get a type mismatch error. How to solve that? You convert the integer into short format. So how to convert? Right side variable before, put a parenthesis. Parenthesis inside what you need to write? Left side data type you write. Now this I will convert into short format. So this is the how you can do a typecasting. So here memory sizes are different. That's why you are typecasting into I also converting into 16 format. So float f equal to 3.5 and int I3 equal to f. But both are same memory size, right? Float to integer same memory size. But what is the problem here? Why you will get a type mismatch error here?
Yeah, float is a decimal values, right?
Good. Float is a decimal. In left side one I3 is an integer. different data types. That's why you are getting a type mismatch error. How to solve that? You convert the float into integer. What is the integer number in the 3.5?
Yes, sir.
Huh?
Float.
In the 3.5, what is the integer number was?
3, sir.
3.
3, right?
Yeah.
Then why are you doubtfully telling? So 3, right? So I'm converting now, this f is converted into integer. In this 3.5, integer is 3. So you'll get a 3. Next. So when you don't need a typecasting, is, say, short S3 equal to 5. Int I2 equal to S3. Why you don't need typecast here? This is the 16-bit. 16-bit will easily fit in 32-bit, right? Still 16-bit left there. So that's why you don't need a typecasting. In the case of left side, more memory size is there. And another one, char C equal to A, capital A. Int I equal to C. Now what will store in the I? So every character has a ASCII codes. Every character has a ASCII code. So what is the ASCII codes? ASCII codes are numbers. Basically, every ASCII code. Okay, so capital A starts with a 65 ASCII code. Capital B starts with a 66. Like that, we have a ASCII codes. So ASCII codes. Let me give you ASCII table. Okay. So this ASCII table, if you see this ASCII table, 65 is the capital A. Small a ASCII code, 97. So like this, you have all ASCII codes. So when you assign the character to any integers, the number will be stored in the integer variables. So when you assign a character to integers, the number will store in the variables. So that's the logic you need to remember here. So char C equal to capital A. Now C, you are assigning C variable, character variable to integer. Now C equal integer number. What is